Let's now talk about an application of software-defined networking, which is network virtualization. So we'll talk first about what network virtualization is, then we'll talk about how it's implemented, and then we'll talk about some examples and applications, such as Mininet. So network virtualization is simply an abstraction of the physical network, where multiple logical networks can be run on the same underlying shared physical substrate. For example, a logical network might map a particular network topology onto the underlying physical topology. And there might be multiple logical networks that map onto the same physical topology, and these logical networks might actually share nodes and links in the underlying physical topology. But each logical network has its own view, as if it were running its own private version of the network. Now you can see from this picture that the nodes in the physical network need to be shared or sliced. So the nodes in the physical topology might be virtual machines. Similarly, a single link in the logical topology might map to multiple links in the physical topology. The mechanism to achieve these virtual links is typically through tunneling. So a packet that's destined from A to B in the logical topology might be encapsulated in a packet that's destined for node X first, before the packet is decapsulated and ultimately sent to B. It may also be easy to understand virtual networking as an analogy to virtual machines, which you may be familiar with already. So in a virtual machine environment, we have virtual machines where a hypervisor arbitrates access to the underlying physical resources, providing to each virtual machine the illusion that it's operating on its own dedicated version of the hardware. Similarly, with virtual networking, a network hypervisor of sorts arbitrates access to the underlying physical network to multiple virtual networks, providing the illusion that each virtual network actually has its own dedicated physical network.